Types of Dimensions is brought to you by CADModelingHub.com. If you have not yet subscribed, please go to my website and take a few minutes and subscribe so that you will not miss any new lectures, tutorials, or future blog posts. By the time you have finished this lecture, you will be able to answer the following three questions. What are the two practical rules of good dimensioning? What are the two classifications or types of dimensions? And three, what are the 5 common dimensioning styles? Mechanical parts and components are composed or created from a number of features. This simple part illustrates this fact. A rectangular plate is the base feature that other features are added or subtracted from. A rectangular boss feature extends from the bottom of the plate. Here is a rectangular pocket feature that was subtracted from the plate feature. Next, notice the cylindrical boss feature that rises from the top of the plate feature. From the cylindrical boss feature, a rectangular slot feature was subtracted. Hole features were subtracted from the plate and cylindrical boss features. Finally, rounds and fillet features were added to smooth the edges and intersections of the united features. So the problem that arises once a model has been created is, how does a designer, modeler, and/or engineer communicate to the manufacturer or supplier what is represented by the model? Today, this is done through the use of dimensions that are placed on the model, called Product Manufacturing Information, or PMI for short, or drafted dimensions that are placed on a paper drawing. PMI will be covered in detail in a future lecture. Here I will focus on the general rules for placing dimensions on a paper drawing. Rule number 1, every feature must be sized. This image shows two views of our 3D part. Notice how the rectangular plate is sized by 3 dimensions, a length, width, and thickness. The rectangular pocket is likewise sized by 3 dimensions, a length, width, and a depth. Pause the video and take whatever time is needed to understand how each feature has been given its necessary size dimensions. Here is what the actual size dimensions look like. If necessary, pause the video so that you can study what message the actual dimensions convey. Rule number 2, every feature must be located. The rectangular plate feature does not need location dimensions, but all other major features need to be located on this plate feature. For example, the rectangular pocket is located with respect to the front and right faces or edges of the plate. The 4 holes are located with respect to the center line or axis and with respect to the right edge or face of the feature. Generally, it will take at least 2 dimensions to locate any feature, with the 3rd location dimension being implied or specified. Pause the video and study each of the location dimension, making sure you understand why, how, and what these dimensions refer to. Here is what the actual location dimensions look like. Now, if we bring both size and location dimensions together, the dimension views of the drawing would look like this. Replacing the red text with actual dimensions, the drawing would appear this way. Pause the video if necessary and study what the combined dimensions are communicating and why the views of the drawing are fully dimensioned. So as a general classification schema for dimensions, they are either size dimensions or location dimensions. Pause the video and practice identifying which of these dimensions are location dimensions and which are size. The next topic I wish to cover is dimensioning styles. Here I will briefly discuss 5 popular styles. You should learn the names of these styles and be able to look at any engineering drawing and identify which dimensioning style is used. Later lectures will be devoted to each style, their rules, advantages, and disadvantages. The 5 styles are standard dimensioning, baseline dimensioning, ordinate dimensioning, tabular dimensioning, and the special case of geometric dimensioning and tolerancing, or GD&T for short. Here is an example of standard dimensioning. Location and size dimensions are distributed around each view. Here is an example of baseline dimensioning. To start the process, one must begin by choosing baselines that location and some size dimensions extend from. The next example is one of ordinate dimensioning. Notice the absence of horizontal and vertical dimension lines and arrowheads. These have been replaced with simple extension lines and values indicating the size or location from the ordinate or 0 position. In ordinate dimensioning, circles and arcs are still dimensioned using a standard dimensioning practice. Here we see a rectangular plate and a number of holes of varying sizes. It is dimensioned using a tabular dimensioning style. The view is annotated with labels, in this case A1 through A10. And a table is provided that locates each hole and specifies its size or dimension. Our last dimensioning style or example uses geometric dimensioning and tolerancing to not only specify size and location of features, but to also use special feature control frames to specify such things as basic dimensions, true positions of holes, cylindricity, and so forth. Remember, each of these styles will have one or more full lectures to take a deeper dive and teach their rules, techniques, advantages, disadvantages, and so forth. In summary, what are the 2 general rules of dimensioning? What are the 2 general classifications that dimensions fall into? Can you name and describe the 5 dimensioning styles introduced by this lecture?